Everybody go ahead. I got 6 factorial divided by 1. All right, so I think we're going to do 6 times 5 times 4 times 3 times 2 times 1. So we'll say 6 times 5 times 4 times 3 times 2 times 1. And what answer do you get when you multiply all of those? Cool, thanks, Samantha. So you get 720. And that's your answer. Any question in regard to how we got that first problem?
No.
All right, so I'm going to show you another way you could do a permutation problem. And this one kind of using your logic.
Hey, Professor, what had you said N stands for again?
N is how many people we're selecting. Or sorry, N is how many people we have to select. All right. So say if we're arranging these president by order. So we're going to put somebody in the first place, second place, third place, fourth place, fifth place, and sixth place. So if I'm just randomly guessing, how many people can I put in first place?
One.
Well, here, let me rephrase that. How many options do I have to put in first place?
6.
Cool. So we'll put 6 right here. All right, so let's go on to the second place. So for second place, how many options do I have to put in second place?
5.
Yeah, good, 5. So you're not gonna put the same person twice, so it should be 5. What about for the third position?
4.
Cool, 4, then 3, then 2, then 1. And isn't that what we did when we did the permutation?
Mm-hmm.
Cool. So that's one other way that you could do it. So you don't technically have to use a formula. The formula is pretty much a way to do it. But if you kind of just think about it logically, and you think about it like every time you select a person, you're going to be choosing one less person. All right, so let's move on to this next one. So this one says, in a race in which 6 automobiles are entered and there are no ties, in how many ways can the first 4 finishers come in? So for this one, how many cars are entered into the race?
6.
6.
Cool. So that means N is equal to 6. How many positions do we care about?
4.
Yeah, 4. So that means that's our R. And for this one, does the order matter who come in first, second, third, or fourth?
No.
Well, wouldn't it matter?
No.
Well, wouldn't first place mean they won the race? Second place mean they came close to first place?
Yeah.
Yeah, so wouldn't the order right here matter?
Yeah.
Yeah. So the order right here will matter. So that way this is permutation again. So if you want, we could do it right here where we could do first place, second place, third place, and fourth place. So for this one, we could say, how many options do we have? How many people could come in first place? Or how many options do we have?
6.
Yeah, 6, yeah. What about second place?
5.
4, 3.
3.
All right, so let's multiply that out. So we get 6 times 5 times 4 times 3, and we get 360. So there's so many different ways that you could have these first 4 positions. So one person could finish first and the second person. So that's going to be one way. But there's a total of 360 way that they could finish. Any question in regard to the second problem?
No.
The 360 came from multiplying those 4 numbers, right?
Perfect, yeah. So you multiply these 4 numbers.
Okay, thank you.
All right. So let's do this last one. So for this one, says a corporation has 10 members on its board of director. In how many ways can it elect a president, vice president, secretary, and treasurer? All right. So for this one, how many different people do they have to choose from?
10.
10. Cool. How many positions do we have to fill?
4.
4.
And for this one, does it matter how they arrange them of president, vice president, secretary, and treasurer?
Yeah.
Yeah, because pretty much you'll have different duty and different pay. So that's why this will be, once again, permutation. Everybody good for permutation on this one?
Mm-hmm.
Yes.
So we have the president, we have the VP, we have secretary, and we have treasurer. So for this one, that should be 10. For VP, once we choose our president, that means we only have 9 to choose from. Once we choose our president and VP, we only have 8 people to choose for secretary. And lastly, 7 people for treasurer. So you multiply all of these out. Let me see, what do I get? So you get 10 times 9 times 8 times 7. And you get 50, 40. Right. Any question in regard to these last 3 problems?
Nope.
And also, yes, no, other way I could write this is 10p4. The p right here stands for permutation. Okay. So I'm going to show you how to do this also with class calc. So what we're going to do this with this last problem that we just did. So let me share my screen. Is everybody able to see class calc?
Mm-hmm.
Cool.
Yes.
All right, so the first thing what you want to do is make sure you're in graphing mode, because you don't want to be in scientific mode, because that wouldn't work. You want to be in graphing mode. So once you're in graphing mode, you want to go right here where it says stats. And if you look right here in the middle, does everybody see where it says NPR?
Yes.
Cool, so let's press it. So if you look at it, it says NPR, and then it's telling us what to enter. So the first thing we're gonna enter is the N. So you go 10. Second thing, what you're gonna do, enter the R. R in this case is 4. And we're done. So that's how you can double check your answer using class calc. Any question in regard to permutation? Sweet. All right. So I'm gonna go back. Let me see how it changed. All right. So let's go back to my iPad. All right, so we're gonna go on to page 25. Oh, sorry, page 26. All right, so for this one, we're gonna do permutation rule again. The only thing that's different is the very first one. So if you look at this rule is different now. So if you remember from the last one, we had n many objects and each item were different from each other. In this case scenario, we're gonna have items that repeat. So not all items are gonna be different. You're gonna have some items that actually are multiple of the same thing. So for that one, gonna be a little bit different. So instead of having like 10 unique people, you might have 4 unique people and 6 people that are the same. Or you might have 4 people that are unique, and then 4 objects that are unique, and 6 objects that are repeating. So for right now, you kind of just go with that logic, and once we do a problem, hopefully that should make sense. So let's do this first example. How many ways can the word Mississippi be arranged? So for this one, are all the letters different?
No.
No, so we have letters that are repeating, correct?
Yes.
Cool. So that's why for this one, you want to do this next formula because you have objects that are repeating. Cool. So for this one, we're going to find what n is. N is still going to be how many total, in this case, letters do we have? So how many total letters does Mississippi have? 11.
11?
Yeah, 11. All right. Everybody good how we get the 11?
Yeah.
Cool. All right, so here comes the important part. What you have to do, you have to look at each object in those 11 and see how many times does it repeat. So let's look at the letter M. How many times does M repeat?
1.
1.
One time.
What about I? How many times does I repeat?
4.
4.
4.
4. What about the letter F?
4.
4.
Nancy, what about the letter P?
Twice.
2.
So far, everybody go. M is 1, I is 4, S is 4, and P is 2.
Mm-hmm.
All right. So if you look at this formula right here, the formula right here says n factorial. So on the top, we're going to put 11 factorial. Everybody good with 11 factorial?
Mm-hmm.
All right. So now in the bottom, if you look at it, it says N1, N2, NK. So that gives me how many different categories do we have that are repeating. So if you look at it, we have M that only repeat once. So that means we're going to put 1 factorial. If you look at I, how many times does I repeat?
4
4.
times.
4, so you put 4 factorial. What about the letter S? How many times does S repeat?
4.
4.
4 factorial. What about the P?
Twice.
Yeah, so you put 2 factorial. Everybody get so far how I got the bottom?
Yep.
So the top is how many, pretty much in this case, how many letters do we have? In the bottom, you have to put how many times did each letter repeat. So let's go ahead and let's do class calc. So right here, what we want to do so we'll put division. We'll put 11. And then if you go to stats, if you look right here where it has an exclamation point, want to press that. And then the bottom, we'll put, well, if I do 1 factorial, what is 1 factorial equal to?
0.
Not 0. Well, 1 factorial, you just do 1, and then that's it. So 1 factorial is actually just 1. So I'm not going to put that. So we'll put 4 factorial, and then we'll put 4 factorial, and then finally we'll put 2 factorial. And I think I did something it doesn't like. Yeah, there you go. Let's do multiplication. All right, so if I do 11 factorial divided by 4 factorial times 4 factorial times 2 factorial, and we get 34,650.
Okay.
And that'll be our final answer for that last problem. All right. Everybody got on that first example?
Yeah.
Sweet.
Yeah.
All right. So let's do this next example. So for this next example, it said if there are 4 chocolate chip, 2 oatmeal, and 2 double chocolate cookie in a box, and how many different orders is it possible to eat all of these cookies? So let's try figuring that out. All right, so how many total cookies are there?
8.
Perfect. Sure, I'll do the factorial on this next problem. So if you look at it, there's 8 total cookies. Because if you go 4 chocolate chip plus the 2 oatmeal plus the 2 double chocolate, that add up to 8. So for n we'll put 8. Cool. So now what we're gonna do, we're gonna list out all of the different type of chips. So we have chocolate, we have oatmeal, and we have double chocolate. All right. So how many chocolate chips do we have?
4.
Yeah, 4. So you put 4 right here. How many oatmeal do we have?
2.
2. And double chocolate?
2.
Perfect. So the way we'll write this, we'll say 8 factorial divided by 4 factorial times 2 factorial times 2 factorial. Everybody good how I got 8 factorial divided by 4 factorial times 2 factorial times 2 factorial?
Yes.
Okay, so take a minute in your class calc, try doing this. For this one, I'm going to do it using the TI-83, 84 for the people who are using the TI-83 or 84. So that way they could see how does that work. So let me share the TI-83 and 84 right now. All right, so everybody should be seeing a TI-83, well, 84. So in yours, what you want to do, you're going to do, what is it, 8 factorial? So you do 8. You hit this button right here where it says math. And then you go all the way over to PRB. And then if you look right here in number 4, you have the factorial. So in case you didn't get that, let me do it again. So you put 8, you hit math, and then you go to PRB, and you go all the way down right here where it says factorial. Then you divide it, and you want to do 4. Oops, 4 with the factorial again. And you multiply that by 2 factorial. And you multiply that again by 2 factorial. So the parentheses, and you get 420. All right, so everybody should have known 420 for that second problem. Any question in regard to that second problem?
No.
All right, so what I want you to do, I want you to practice on this next problem. So it's the same thing. It'll be permutation with items that repeat. So try doing that. If you need any help, either shout out what question do you have, or if you want, just not email me. Just send me a question on the chat, and that way I'll try responding to you on the chat line. But just try practicing on this one. So what should I put on top?
13.
Which one?
13.
13, yeah, good. So you want to put 13 factorial. Perfect.
Why 13?
Well, if you count them, you go, they're 2 small, they're 3 medium, so that's 5, plus 6 large, so that's 11, plus 2 extra large, so that's 13. So if you count how many total shirts there are a total of 13 shirts.
Oh, I put 4 for the sizes.
I did too.
That's why I got a decimal point, and I was like, what?
Yeah, well, that's a good way to kind of figure out if you're going on the wrong path. If you ever get a decimal,
Yeah.
there's something wrong. It should always be a whole number. So that should, like, the good thing is you were kind of able to understand, hey, something is definitely wrong because I cannot get a decimal value.
Right.
That's what I thought too.
Okay, so now that we fixed that, it should be 13 factorial, not 4 factorial. What's the first factorial I should put on the bottom?
2
Yeah.
factorial, 3, 6, and 2.
Cool. So you want to do 2 factorial times 3 factorial times 6 factorial times 2 factorial. So we're actually going to do that in class calc.
Okay, so did you put the first part just to like confuse it, or because I got confused when it said 4 sizes? I thought you. Okay.
I didn't do it to confuse people. I did it just to say there's only 4 sizes, but you have to look at how many times they each size occur.
Okay.
And then purposely go like, I want to just trick these people. Like, okay, so we want to put 13, and then we do factorial,
Mhm.
and we go divide, and then we do 2 factorial, and then you say multiply by 3 factorial, and then multiply by 6 factorial, and then multiply by 2 factorial. Cool. And you get 360, 360. So good job, Alondra. You had it all along. So we'll share my iPad for that way you can see what I just wrote down.
Okay. I got that.
All right. Everybody good on 360, 360?
Yes.
All right, cool. So that's permutation when we have identical object that repeat. So it shouldn't be that bad. Like you have to be able to tell the difference between permutation that all of them are different and permutation where some of them actually do repeat. So if they do repeat, you want to use the second formula. If they don't repeat, you use the first formula. Any question in regard to permutation?
No.
So up next, what we're gonna do something called combination. A combination, pretty much the first 2 are the same as the first permutation. So there's n different items, so that means there's no item that repeat. R is selected without replacement. But in this case scenario, it doesn't matter the order. So A, B, and C, and C, B, and A, that will be considered the correct answer. So if you have A, B, C, C, B, A, that will be considered the same because the order doesn't matter. Any questions so far on the difference between combination and permutation?
No.
Okay. So let's go ahead and just go straight to a problem. So it says, suppose you find 7 articles related to a topic of your research paper. In how many ways can you choose 5 articles to read? So for this one, how many articles do they have to choose from?
7.
7. are any of the article the same article, or can we assume all the article are different?
They're different.
Cool, so they're different. Do they tell us how many article are they going to read?
5.
Yeah,
Yeah.
5. So R is equal to 5. So for this one, does it matter the order that this person read the article?
No.
Not really, because since they're gonna read all 5 of the articles, it doesn't matter who they choose first, second, third, or fourth, or fifth, because pretty much they're gonna read all 5 of the articles. So in this case, order the cool. So since order doesn't matter, that's why we're gonna do combination. Everybody get why we're doing combination versus permutation?
Yes.
Yes, you do have a question, or yes, you're good with it?
Yes, I'm good with it.
All right, cool. Sweet. All right, so up next, we're gonna go ahead and do the math. So if you look right here, it says n factorial. So that means we're gonna put 7 factorial. If you look right here, it says n minus r. So if I do 7 minus 5 factorial, and then right here is r factorial, so that means it is 5 factorial. So if I do some algebra, 7 minus 5, will you give me 7 factorial divided by 2 factorial times 5 factorial? All right. Everybody got how I got 7 factorial divided by 2 factorial times 5 factorial? All right, so right now I'm going to switch it over to class calc. I'm going to do that multiplication. So we're going to say 7 factorial, and we're going to divide that by 2 factorial, and then we're going to multiply that by 5 factorial. You get 21 and 21 your answer.
I don't have my.
Cool, thank you. All right. Everybody got how we got 21?
Mm-hmm.
All right, sweet. All right. Also, in this one, it does have an option for you to do it. So if you go to stats, if you look right here where it says NPR, if you look right to the left of it, it says NCR. So if you put NCR, you can put 7, 5, and it'll give you 21. So
Okay.
should be nice and easy. Once you're able to identify its combination or permutation, pretty much there is literally no math to it. You're gonna let class calc or TI-83 or 84 do the work for you. But any question for that first example? All right, so let's go over that to the notes. So for this one, it says a team of 17 softball players need to choose 3 players to refill the water cooler. So for this one, how many softball players do we have to choose from?
17.
17. So that means n is equal to 17. How many of these 17 softball players are we actually going to choose?
3.
3. So we say R is equal to 3. For this one, does it matter who I choose first, second, or third? Or is it all the same?
All the same.
It's all the same because at the end of the day, they're going to go refill the water cooler. So it doesn't matter who they choose first, second, or third because they're all going to do the same thing. So this is a combination. So technically, we could just write it as 17C3. So if you do 17C3 in class calc, what do we get?
$680.
Yeah, 680, good. And that's the answer for that. Any question in regard to how we got 680 for that last problem?
No.
All right. Alright, so let's apply what we have learned right now. So for this next example, it says in Pennsylvania, match 6 lotto, winning the jackpot require you select 6 different number from 1 to 49. The winning number may be drawn in any order. Okay, so let's see if this is a combination or this is a permutation. So for this one,
Combination.
perfect. Everybody on time. Well, how do I know this is a combination?
Because you can use the same number.
Not because I could use the same number, that's a key thing that they tell us.
It doesn't matter the order or.
Yeah, so they'll draw it
Any
in
order,
any
okay.
order. So it doesn't matter if you chose the winning number, the 6th number, or the first time. The order doesn't matter how you select it. So this is combination. So how many numbers do I have to choose from?
49.
49. How many number am I choosing?
6.
6.
6. So we're going to say 49 C6. So here, let me switch over to class calc in case you want to see this.
A long number.
That's why we chose the lottery. So you want to do 49, and then we'll do 6. So if you got the number, there's 13,983,816 different combinations.
Still confused. Well, everybody will take it 13,983,816. All right. So up next, what we want to do, we want to find the probability of winning, of you getting the winning ticket. So for this one, how many winning tickets will they be? 1.
Cool. So you have 1 out of 13,983,816.
Good side.
So if we do that probability, I'm pretty sure that probably won't even show up. So if we actually do this, you should have 1, 2, 3, 4, 5, 6, 7. Cool. All right, so that's the probability of you winning that lottery ticket if you buy 1 lottery ticket. So the chances of you winning that lottery ticket, well, of you winning with that 1 purchase, is not very likely. And that's it for that last problem. Any question for the last problem?
No.
Sweet. All right, so we're all done with chapter 4.
That was chapter 4.
Cool. All right, so that's chapter 4. So let's do this.